Good evening. Today I would like to explain my conference paper title is Assessing the Role of Machine Learning Models in Groundwater Contaminant Monitoring and Management. So let me justify my title. I'm taking as a groundwater contaminant as a data set to my system and I'm applying machine learning algorithms. I'm finding the output with the concentration levels of PFAS, that is contaminants concentration levels we are finding by using machine learning algorithms. So warm welcome for this conference Adelaide 2024 and myself Dr. Asadi and my colleagues are Dr. Alvin Lal and Laureate Professor Ravi Naidu, and I have done my PhD in Artificial Intelligence specialization and I have 22 years of teaching experience and I'm working on various environmental case studies in the GSER department at the University of Newcastle, Callaghan, Australia. These are my contents of my conference paper title: Introduction, Objectives, Methodology, Results, Discussion, Future Directions, Conclusion, References. And coming to introduction, so there are various types of groundwater we are utilizing, like surface water, drinking water, and wastewater. Okay, so in this groundwater, a subsurface water source may become contaminated and needs advanced monitoring and management for safety. And this groundwater contamination poses significant environmental challenges and also public health challenges are available. In order to avoid those challenges, we are applying machine learning algorithms. Coming to monitoring and management involve using machine learning models to detect and predict groundwater contaminants concentration levels of PFAS, enhancing decision making for effective environmental protection. Monitoring and management uses various machine learning, deep learning, artificial intelligence, statistical methods or models to detect groundwater contaminants, improving decision making for protection, for public health and for societal use. So we have collected the literature survey on 10 papers closely related to groundwater contaminant monitoring and management. So we have segregated columns like author details, title of the paper, country of location, challenges and issues, case study, and methods and algorithms, results or findings. So we are finding common drawbacks of all the 10 papers and what are the challenges we are avoiding in the proposed system by using various AI, machine and deep learning techniques. Okay, so then machine learning algorithms, ML techniques in groundwater management are increasingly used to enhance the accuracy, efficiency and effectiveness of monitoring and predicting groundwater contamination. So there are various challenges like contaminant transport modeling, pollution source identification, water quality assessment, groundwater quality modeling, etc. Then the objective of our conference paper and research paper aims to assess the effectiveness of various ML models in groundwater contaminant monitoring and management. Then methodology includes various steps we are performing and it addresses contamination issues by analyzing case studies and data and performing comparative analysis to manage groundwater pollutants. So we are applying investigating machine learning applications to solve contamination issues. Then examine the case studies and empirical data. Finally, we are comparative analysis to show machine learning advantages over traditional methods and by using advantages of machine learning in managing groundwater pollutants. Then if you see groundwater contaminant management with machine learning, we have 10 case studies and results finding. So in the first case study, they have used in contamination management. So what they find, comprehensive review of AIML and potential in contamination management. Then the second case study, deep learning emulators for groundwater contaminant transport. So they have found out improved accuracy and efficiency in predicting contaminant transport dynamics. Likewise, the last case study, machine learning for source identification and network optimization in Greece, enhanced source identification and monitoring optimization. So finally, discussion of results by using AI, ML and DL methods such as deep learning emulators, artificial neural networks and optimized models enhance groundwater monitoring, accuracy and efficiency. And by using U and his team, they have developed the concept called deep neural networks, DNN, effectively modeled groundwater contaminant transport, greatly improving prediction accuracy and efficiency compared to traditional models. And according to Mazumdar and his team, they have implemented an optimized machine learning model using XGBoost enhances prediction accuracy and reliability of for groundwater contamination, emphasizing the importance of parameter optimization. Then coming to conclusion, by using machine learning techniques enhance groundwater contamination management by improving accuracy, modeling and optimization across diverse applications. Research suggests enhancing machine learning algorithms, incorporating real-time data and expanding their application across diverse environments for better groundwater management. So these are the references I have used for my research in GSR. These are the 10 closely related literature review papers. Thank you for giving me this opportunity.